In this video, we are going to simulate full wave rectifier controlled by thyristor. This is the question. Design, simulate and analyze single phase full wave rectifier controlled by the SCR or thyristor with the following details. The details are Vm is equal to 100, that is maximum voltage or peak voltage is equal to 100, resistance equal to 1 ohm, phase delay or delay angle is 45 degrees. So this is the initial settings, and these settings are modified as resistance 1 ohm is changed to 2 ohm, and then we have to observe what is the change in the current waveform, and then later the 45 degree is changed to 90 degree, and then we can note the changes in the output voltage and the current waveform, right? Finally you can write the inference. This is MATLAB home page. Let's create new Simulink model. Choose blank model here. So this is the blank model. Let's get all the components. First one, AC voltage source. So we got AC voltage source. Next we need thyristor. So control R to rotate the thyristor. Let it be like this. Double click the thyristor. Disable show measurement port. Make this as simple. So let's copy. Right click and drag to copy. So we need 4 thyristors. So right click and drag. So we get 4 thyristors. Next we need series RLC branch. Series RLC branch. Double click and make this as resistive branch. Apply OK. Control R to rotate. And now let's connect all the components. So this one cathode to anode, cathode to anode, cathode to cathode, anode to anode. AC voltage source is connected like this. Next the resistance branch is connected like this. So we have connected all the components. We need gate pulse for all the thyristors. So we need pulse generator. Double click the pulse generator and let's change the default settings. Amplitude is 1, period 50 Hz means 0.02. Pulse width is 10%. Phase delay, since the delay angle is 45 degree, we need to set 45 divided by 360 into 50, right? Apply OK. So this is going to control the positive half cycle. So let's give it to this thyristor and this thyristor. Now we need a pulse generator to control the negative half cycle. So right click, drag the pulse generator. Let's change the settings. Amplitude is 1, period is 0.02, pulse width is 10%, phase angle. So in order to control the negative half cycle, we need to give pulse at pi plus 45. Pi plus 45 means 180 plus 45. That is 225. So 45 becomes 225. Apply OK. This one we are going to give it to this thyristor and this thyristor. So we have given gate pulse for all the thyristors. Double click AC voltage source. Change the frequency to 50. Apply OK. Double click resistance branch and the resistance value is 1 ohm. So let's click OK. Now we need a measurement block, voltage measurement block. Voltage measurement block. We are going to measure the output voltage and the input voltage. So We need one voltage measurement block to measure the output voltage. We need another measurement block to measure the input supply voltage. So we have two voltage measurement, and we need one current measurement block. Current measurement block, let's connect it in series. It's connected in series. So we have current measurement block. We need scope to see all the components, all the waveforms. Scope. So in the scope, we are going to connect the supply voltage, then the gate pulses and output voltage, and finally output current. So we need 5 inputs, one for supply voltage, two for the triggering pulse. So that makes 3. Output voltage is 4. Current waveform is 5. So double click scope, click the settings. Number of input port is 5. Click the layouts. Double click scope. Click the settings. Number of input port is 5. Apply. OK. So here you can see 5 input ports. Double click. Change the layout. Layout. So 5 layouts. So we get 5 graphical inputs. So first one, we are going to connect the supply voltage. That is the first one. Next, triggering pulse. So this one is going to control positive half cycle. So let's give it as a second one. And this pulse is going to control negative half cycle. So third input. The next one, output voltage, is the fourth input. Finally, current waveform will be the fifth input to the scope. So now we have given all the connections. Now let's simulate and let's run the simulation. So stop time. Stop time, let's keep it as 0.1. So we will get 5 cycles. Then we missed power guide. So double click power guide. Double click this one and make it as discrete. Apply. OK. Now let's run the simulation. And let's observe the readings. Double click the scope. Maximize. So the first waveform is the supply voltage. Second one is the gate pulse for positive half cycle. And the third one is the gate pulse for negative half cycle. This is the output voltage and this is the output current. You can see the magnitude of output voltage is 100 and the magnitude of output current is also 100. So now we are going to change the value of resistance and note down the changes. The value of resistance should be changed to 2. Apply. OK. Let's run the simulation. Double click. And here you can see the change in the magnitude. This is output voltage. The magnitude of output voltage is 100, whereas the magnitude of output current is just 50. Next, we are going to change the delay angle or firing angle to 90°. So for that, we have to change this 45 to 90°. 90°, apply, OK. And here 5 plus 90. That means 180 plus 90. 180 plus 90 is 270. Apply, OK. And now let's run the simulation. Double click the scope. And here you can see the output voltage and the output waveform. So that's all about the full wave rectifier controlled by SCR.